Welcome to all in this lecture on elements of laser. As we have discussed in the previous lectures, then laser is a light that can be created by some arrangements. So what is needed to get lasing action will be discussed here. The laser system consists of several parts. We will discuss the role of each part and the classification of each part in this lecture. Following are the outlines of this lecture. We will begin with learning outcome and student effective learning outcome of this particular lecture. Then we will discuss parts of laser and functioning of each part, classification of each part. We will discuss these things separately. And finally, we will discuss the possibility of betterment and applications, exercise for you, and references in the end. With this lecture, you will be learn about how the best laser can be obtained. We will begin with the basic lasing system. Then we will also discuss how the improvement has been suggested or had been implemented in lasing system. The efficiency of lasing system is one of the biggest challenge. How we have overcome this challenge we will discuss here, and we will move to the present kind of lasing system after that. Of course, such lecture will provide you ability to solve problem through application of theory and practical concepts. This will also develop a critical and innovative thinking skills in you. In this part, we have discussed a brief about laser construction. We have studied this many points on this laser construction since beginning, types of radiations, then resonance, amplification. We have discussed these things, but here I am consolidating the results again before, because in the next lecture we will move to various examples of lasers. So as a conclusion, the laser system consists of three important components: uh, pump, pumping mechanism, lasing medium, and resonator. Broadly, only three things are there: a mechanism to pump the system, because we know the population inversion is the essential condition for the laser. And since this condition is artificial condition, so you have to create a pumping mechanism. How to pump? Second thing is laser medium, where you will get the lasing action. So raw material realization is possible. And third is, after getting this stimulated emission in these two using pumping source and medium, you have to amplify the signal. So we need optical resonators. There are three things. We will discuss these things one by one. Before learning the details about pump source, we must go into idea of pumping. Why pumping is needed? Pump source means a source of energy that can be supplied to lasing material so that the atoms can get the energy and move to higher energy states. But the question that may come in your mind, then why pumping? I just remind you the previous lecture on lasing action conditions. For lasing action, it is needed that the higher state or the excited state must have more excited atom than the ground state. If we consider the higher state population as N2 and ground state population as N1, then N2 must be greater than N1, and not only greater but very greater than N1. This is called a condition. This is necessary. This is called condition of population inversion, and that is needed for pump lasing action. So you must understand the need of pumping sources for pump the system. Pumping is the act of energy transfer from external source to laser material. Whenever we give pumping, the electron or atom move to excited state and finally the atom move to higher state. Excited atom are needed for lasing action. So pumping is one of the important part of lasing system. And with this we can create lasing action. The pumping should be continuous and should be in such a way then we can create condition of population inversion. The condition of population inversion require the more number of atom on excited state than ground state. As it is shown here, initially the ground state have more atoms than excited states. You can see here more atoms are there. Now we send photons here. Here we have shown the pumping through optical lights. So whenever you give this, this atom wants to go here. This is called excited state. And soon you will see that this level is less populated than next level. And that is the reason a condition of population inversion achieved here, which is needed for lasing action. So first thing is pumping source. The pump source or ended source is the part of lasing system that provide energy for lasing laser medium. And this is needed to send from atom from ground state to excited state to achieve population inversion. In the case of population inversion, higher energy level should be highly populated than lower energy. So this is the process of achieving greater number of electron and higher energy. So for this we use pumping. These sources supply sufficient amount of energy to the laser medium by which electron in the lower energy excited to go higher energy states. Examples of these sources include electric discharge, light from another laser, chemical reactions, flash lamps. The type of energy source used in mostly depend on lasing medium. Excimer laser use chemical reactions, a helium layer use electric discharge, and device use optical discharge. So different type use. Many types of pumping methods are there, but two are very dominant, very significant. One is optical pumping and another is electrical discharge pumping. We will discuss these pumping in detail when we talk with some specific lasers like ruby laser, helium neon laser, CO2 laser. But here, just to introduce the subject, one is optical pumping. As it is clear from the name, in optical pumping we use optical photons or light to pump. Such type of pumping we use in solid lasers. In solid laser, we use some flash lamps, krypton, xenon, and when we lit these lamps, they pump the system. The optical pumping is always easy to explain because photons are incidenting on the ground and these photons are exciting the atom to the excited state. Whereas in electrical discharge pumping is done in gaseous lasers like helium neon, like CO2. In this type of pumping, we put the gas in an electrical discharge tube, thin tube, and we apply electric discharge between the two electrodes so that the atom get excited and move to excited state. Many other methods may be used for dye sensors, lasers, but these two methods are dominant. The details of these pumping will be discussed while we talk about the gas lasers and solid lasers. If we want to create a laser, the most important thing is lasing medium. Laser medium is the medium where we generate stimulate emission. Basically, this laser medium again consists of two parts: active center and active medium. In active center, those atoms which are directly involved in laser action. Whenever we pump the system, these atoms directly take the energy and move to excited state, and they give you laser action. And then, other than whatever you are having in the laser medium, other than active, is called active medium, which supports lasing action. Yes, active center should be supported by active medium for obtaining lasing action. So this is a laser medium. Laser medium, also known as active medium or gain medium, which supports active centers. The laser medium determines the characteristics of laser. The laser medium can be solid, liquid, or gas. In the coming lectures, we will discuss few examples. One example from solid we will discuss, then from gas and semiconductor. For solid, it is named solid because this solid materials. We have ruby laser as an example of solid state. Nd:YAG also a solid state laser. In this unit, we will discuss Nd:YAG. However, UV laser is a first laser developed, in which we have ruby crystal, alumina crystal, and chromium as an active center, and alumina as an active medium. In the case of Nd:YAG, niobium as active center and YAG, yttrium aluminum garnet, is a active medium. In this laser, xenon discharge tube which provide flashlight act as pump source. However, as we discussed, gas lasers are also there. Helium neon laser or CO2 laser, these are gas laser. Helium neon also called atomic laser, whereas CO2 are called molecular laser, in which we use a discharge tube to pump. The laser medium is surrounded by two parallel mirrors which provide feedback of light. One mirror is fully reflective and other is partial. This is third part, apart from laser medium and pumping. This is used to amplify the system. We have devoted a complete lecture on amplification, so you can go through this lecture again if you have go detail of this resonator, how it creates resonance. First, we will have spontaneous emitted photons, then these spontaneous emitted photon will strike on some photons on excited, some electrons on excited state, so this will generate stimulated emitted photons, and then so on. Optical resonator, also known as optical cavity or resonant cavity. These in the we have two mirrors which determine the reflective properties, and optical coating, thin layer material deposited. As one we want one partial reflecting, one fully reflecting, so different coating is there. The output coupler allows some of the light should leave the cavity and move to the output beam, so it is a partial reflected. Other mirror is fully reflected. Actually, the process of emission of photon is called spontaneous emission, and these spontaneous emission photons is used to generate stimulated emission. A large number of electrons are simulated to emit light. the optical gain is achieved. The amplified light escapes through the partially reflected mirror as, as a output. In the process of stimulating electron to other atoms to produce light is called stimulated emission. By this way, we generate laser light. In this lecture, we have studied characteristics of laser and parts of lasing action. We can summarize all the resonator behavior and activities in this 5 figures. It is shown here uh, an optical resonator. You can see here fully reflecting and partial reflecting mirrors. This mirror is fully reflecting when this is partial reflecting. From here we get the output. We have shown all the material with 3 colors. The gray color is showing here the ground state, which you can see in the first figure, then energy level 1 and energy level 2 in the different colors, purple and blue, and finally green spontaneous and yellow stimulated. If you go on through with these figures, then you can see in the first, I'm talking about this first figure on the top, and all our atoms are in ground state, and this medium, lasing medium, is in ground state. Now we apply pump. We pump the system. We pump using energy. Pumping may be electrical, optical, chemical, as we have discussed in the previous slides. Due to this pumping, you can observe here different colors, not green. It means different colors are showing you, some move to first excited state, some move to second excited state. Depends on material to material, but excitation is there due to this energy. This I am talking about the B figure. Now move to C. This third condition is used for spontaneous emission, because after the absorption, the spontaneous emission may take place within 10 to the minus 8 seconds. So the system or the atom want to move to ground state. But at this place, they try to give the energy to the surroundings. Sometimes they may give the energy to the nearest atoms. As we have chosen the material is lasing, so such type of events may happen, and atom may get the energy, and you may use this energy to move to ground state. That is called a stimulated emission. So initially the spontaneous emission started, and then it will convert into stimulated emission. You can observe the stimulated emission. Green showing here the spontaneous emission, and then you are observed some yellow here. This is stimulated emission. And now these stimulated emitted photons will move here and there, and finally only those will survive which are moving along the direction of mirrors, in the axis of mirrors. So they move back and forth in this. You can see here that first they move here, then they reflected back from the mirror and move there, and the intensity increases. And finally, the last we have shown the lasing action can be observed in E. So these are the process of optical resonators. Two questions I am giving you for an exercise. Mention pumping schemes for various lasing materials. Because pumping scheme is different for different materials. So mention few examples from there. Also discuss the difference between active center and active medium. And what is the role of these two things in lasing material? Discuss with this some examples here. These are the references that you can take for further reading. Laser by Avadolu and Shirsagar S. Chand publication, and Optics by A. Ghatak. You can also go through with the website reference if you need. Thank you. Thank you. In this lecture, we learned about various lasing elements like lasing material, resonator, pumping mechanism, and also pumping process and why we need the pumping and population inversion conditions. Take care. Bye.